Hey guys, this is Gabin once again, and today we'll be working on what we have been doing so far. So we have been working on simplifying different expressions that involve fractions, and also we have been learning how to rationalize a fraction, especially when we are dealing with surds. Right? How do you rationalize an expression that involves surds, and especially when there are fractions involved as well. Now, the way you rationalize stuff, if you are not sure, watch the previous video. We did a couple of examples on how to rationalize it, right? So let's look at this particular example that I've prepared and see what we can add to them. All right. So in the first example, we have got 1 over square root of 6 plus 2. Right? So the first question is simplify the following expression and rationalize them. Right? In this one, we cannot simplify anything, however, we have to rationalize it. Right? So the way we rationalize this, remember, in the previous video, I talked about something very important, something that called conjugate, right? Conjugate. So remember if, for instance, I'm gonna write here. So, for instance, if our expression is 1 on a, 1 on square root of a, if you wanna write, the conjugate of this, there's no conjugate of this. However, the way you can rationalize this will just be a 1 on square root of a times by root a over root a. Why? Because this is just times by 1, because I'm not changing anything. I'm doing the same thing at the both sides. However, what happens here, you then end up with root a over a, right? So this one is rationalized. And then if we have, let's say, root a plus b, right? Then here what you have is you have 1 root a plus b, and then you times by because the conjugate is basically a reciprocal relationship, right? A reciprocal relationship between the first fraction and your new fraction that you'll be writing. So the conjugate of this will just be a, instead of plus, it will be minus b over a root a minus b. And when you do this, what you end up with is root a minus b over root a squared minus b squared, right? And that's basically root a minus b over a minus b squared. So you can see this is just a first form that you could have, or you could have this one. So in our situation, we have got the second one, right? So let's apply that to see how we can work out this, how we can rationalize this, right? So I'm gonna rub off this, them off, and then let's move on. Right. So now with this, what you then do is you equalize that, put the sign, and then you have root 6 plus 2 times by root 6 minus 2 over root 6 minus 2. And when you do that, on the next line, what I'm going to have is, when you times this as we saw, it will be root 6 minus 2 over, so this, in our situation, this is acting like our A, and this is acting like our B, right? So what you then have, you have root 6 squared minus 2 squared. If you're not sure how I'm getting this, you can explain this. You can do normal multiplication with these factors and then see what you get. You will definitely get that, right? And if you're not sure, again, watch our previous videos, because we have done something for this one. We have done something similar to this one, right? So if I move on, this off. So if I move on from there, my next line, what I will have root 6 minus 2 over square root of 6 squared. What does that give? Give you 6, right? 6 minus, and then what is 2 squared? It's just 4, right? 4. And then our final answer should be root 6 minus 2 over 2. Right? So that's our final answer, guys. Let's look at the second one. Huh? So I'm gonna write underneath this one because I don't wanna make it so long on the side. So now with this, notice that this is not square root. This is a cubic root, and this is the fourth root of whatever expression that we have got here. And then here, this is the fifth root, right, of a. So now with this one, remember when we have, so for instance, the reason why we call it square root is because it's 2. So when they write this 4 equals 2, right, y could be even plus or minus, but why is this correct? This is because that could be explained by doing this. So that's basically saying it's 4 to the power of 4 to the power of 1 on 2, right, which is equal to 2 squared to the power of a half, which is the same as 2 squared to the power of 2 on 2, and 2 on 2 is just 1, so to the 1 is just 1, right? So that's the idea, Whenever there's not any different number here, or wherever there's no number here, we assume that it's 2, right? It's the root 2. But then whenever they put numbers, that becomes different, right? So for this particular situation here, the way we can write this is you can write the first expression as a to the power of 9 on 3, right? Plus whatever expression this is, which you then be 16a to the 8 b squared, 1 on 4, and then minus 3 times a the power of 15 on 5. So that's the expression now. So you can see the previous we are simplifying, right? We are simplifying. Now the next bit that we have, what is 9 on 3? It's just 3, right? So a cubed. Alright, this again. Yeah, 9 on 3 plus. Now let's do some working here. So remember, it's multiplication in between, and we have got the power. So this is the same as I can break down this as 16 quarter to the quarter, 8 to the power of 8 on 4, b to the power of 2 on 4, right? Minus here, what is 15 on 5? 15 on 5 is just 3, right? Right. So now let's move on to the next line. Remember, when we are simplifying, adding or subtracting same factors, what we look at is we analyze the lucky terms, right? Lucky terms. So you can see here, well, this and this. It's not just because they are lucky, but then the power has to be the same, right? The powers have to be the same. So here you can see that it's to the power of 3 cubic, and here is cubic. So we can add them or subtract them, right? So what you then do, you can collect those ones, and then you have you can then have. So when you add, this is like plus 1, and this is minus 3. So you have minus 2 a to the 3, right? Plus. Now with this one, how can we simplify this? 16, right? 16. So we are looking at anything, what number, how can we write this to make this 16 have b to the power of 4, or maybe something that can simplify to that, right? So now 16, how can you break down 16? What number can we write the power of 2 as well? Here what you can do then, you then have you can do this. You can break this down in terms of 2 times 2 times 2, 4, 8, 8 times 2, right? So to the power, see the power of a quarter. And then what is 8 on 2? Times 8 on 2, 8 on 2, 8 on 4, sorry, is 2. And then b, so b is still, yeah, we still have b being half, right? Now, can we write this better? Yeah, we know that using index law, we know that we can simplify that, and so we have 2a cubed, right, plus 1, 2, 3, 4, right? So that's 2 to the power of 4, and a quarter here, a squared. What is b to the power of that? So that's similar to just this, right? And then my next line, which could then be that cubed plus 4 on 4, 2 to the power of 4 on 4, a squared root b, right? And my next line, which is my final line actually, is just minus 2a cubed, right, plus, because this 4 on 4 is 1 and 2, so 2a squared root b, right? So that's our final answer, guys. Really, you could leave like that, or if you don't want to do that, what you could do alternatively, what you can write the final solution just for the final solution, or you could do for the final solution, you could then have so that's basically 2a squared root b minus 2a cubed, right? That could be written as 2a squared root b minus minus a, right? So I just took the common factor, right? Common factor 2a squared because the lowest, and then we know that in 3 we can have 2. So I hope this concept makes sense, and this I believe was one of the latest maybe question on this stuff that we are doing, simplifying and rationalized denominators. If you have any question, type them in the comment section and I will get back to you as soon as I can. And if you are not sure about how to do this, watch the previous video where we worked on how to rationalize surds, right, using the idea of conjugate, right, conjugate. And if you are not sure about the conjugate is basically saying it's just a reciprocal relationship between two fractions, right, or two surds. And as you can see here, we had root 6 plus 2, but then the conjugate is root 6 minus 2, right? So, and you can see the answer that we go. And with this one was basically dealing with index laws, right? We know that to represent the square root is basically to the power of 1 over this number. Whatever number is there is always 1 on that. If the number inside under the root has a power, then you take the power over whatever number is there. And that's what we did here to get those numbers. And then our next line, we're just simplifying this and expanding the power, distributing the power to each of the factors. And yeah, so our final answer could be this. You can stop here, or it could be even fancy. Yeah, have that, right? Thank you so much, guys, for watching our videos. Like, share, comment, and remember to subscribe to our channel if you haven't done so. See you soon. Thank you.